Hi friends, welcome to Cat Engineers Academy YouTube channel. Myself Tirupati. Okay friends, today we will see how to solve the electrical circuit problem by using mesh analysis. Okay friends, just see here. Here we consider one problem. That problem is find the current I0. Find the current I0 in the circuit by using mesh analysis. Okay friends, it is clear. We have to find the current I0 by using mesh analysis. So just they are given simple circuit. So in that simple circuit consisting of 24 volts source and 10 ohms, 4 ohms, 24 ohms and 12 ohms as well as 4 I0. This is the dependent voltage source. So this voltage source will be depends upon the current I0 flowing through the 10 ohms. Okay friends. So by using mesh analysis we need to determine what is I0 current. They are asking what is I0 current. So how to evaluate this I0 current is nothing but simple procedure. First you have to evaluate the loop currents. Then here we have consider small one I1, one I2, one I3. For example, we are having in that three loops. In that three loops, we will get the three currents. What is I0 is nothing but that current is related to the first loop as well as the second loop. So finally, we will get the I0 is nothing but first loop current minus second loop current. So finally, in order to evaluate the I0, first we have to know what is small I1 and what is small I2. So finally, by using mesh analysis, first you have to determine the mesh currents. Finally, you have to evaluate the I0. So this is the procedure to solve the problem. Then you have to go for the solve the problem by using standard procedure. So according to the mesh analysis, we are having the four steps. Just to follow four steps. So first step is, so step 1 is clear. Step 1 is what is the total number of meshes. So first identify the total number of meshes. Total number of meshes. Total number of meshes. So here total number of meshes are, this is 1, this is 2, this is 3. Meshes is nothing but loops only. Total number of loops. So finally here total number of loops are 3. So meshes are loops are safe. Don't worry, all are safe. Now next step 2. First identify the loops. Next step 2. Assign loop currents. Assign loop current. So here I consider the loop currents are total 3 loops is nothing but small I1 and I2 and I3. So total 3 currents. So how we have to assign the current is nothing but you can consider any direction either clockwise or anti-clockwise. So here I consider the clockwise direction. So finally this is the loop current in this first loop. So this is I consider as a small I1. Next in this loop it is a second loop. Here I consider the second loop current is a small I2. Next this is I consider as a third loop. So finally this I consider as a I3. So finally I1, I2 and I3. This is the step 2. Next you go for the step 3. Step 3. Step 3 is write KVL equations to loops. KVL equations to loops. Now how many loops we are having? 3 loops. So finally apply KVL to mesh or loop 1. Mesh or loop 1. So small I1 with respect to small I1 is considered as a loop 1. So small I1, just listen. This is the loop. In the 24 ohms we are having 10 ohms and 12 ohms. So first you have to consider 24 ohms was negative to positive. So negative to positive is nothing but rise in potential. So always rise in potential you have to consider the negative, and drop in potential you have to consider the positive. Vice versa also no problem, you can consider as you wish, but my method is here I consider this one is negative, next one consider as a positive. So plus 2 minus 20, then we have to consider as a positive. Minus 2 positive is nothing but consider the negative. So minus 34 plus next here 10 ohms into what are the current flowing through the 10 ohms? I1 as well as I2, both the currents are flowing. With respect to first loop, we are writing the equation. So that 10 into I1 minus I2 you have to consider. Next here 12 into I1 minus I3. With respect to first loop, you have to consider I1 minus I3. So finally you get the equation is 10 and 12. Okay, minus 24 plus 10 I1 minus I2. Next plus 12 I1 minus I3 equal to 0. Now simplify this equation. Minus 24 10 I1 minus 10 I2 plus 12 I1 minus 12 I3 equal to 0. So finally we get the I1 22 I1 minus 10 I2 minus 12 I3 equal to 24. Then you have to take the 2 as a common. Finally we get the equation is 11 I1 minus 5 I2 minus 6 I3 equal to 12. Now you have to consider this equation as first equation. Okay friends, first equation is over. Next we'll go for the second loop. Next second loop, apply KVL to mesh loop 2. Loop 2. Now next KVLs for loop 2. Then go for the loop. So loop 2 is nothing but consisting of 10 ohms, 24 ohms and 4 ohms. So finally loop 2 is consisting of 3 elements. Then you have to start the write the equation from 24. For example, you are writing 24 into I2, next 4 into I2 minus I3, because I with respect to second loop, but two currents are flowing, so that I2 minus I3. Next 10 ohms, two currents are flowing, I2 as well as I1. With respect to second loop, we are writing the equation, so I2 minus I1. So 24 I2 plus 4 into I2 minus I3 plus 10 into I2 minus I1, okay, equal to 0 according to the KVL. So first KVL is second loop 24 I2 plus 4 into I2 minus I3, next plus 10 into I2 minus I1 equal to 0. Then you have to simplify this equation. So after simplifying, you get the 4I2, 10I2, 14I2, 24I2. So finally we get the 38A2. Next I3 is only one I3 are having minus 4I3. Next I2, 10I2, 4I2, 14I2. So finally you get the 14 here. Sorry, not I2, I1. I1 is nothing but only we are having the reference. This is 13 I2, next 4 I2 and 10 I2. So 14, sorry, only I3, 14, 4 I3. Next I2 is 14 I2. So 14 I2 is 38 I2 minus 4 I3 and minus 10 I1. Okay. Okay, minus 10 I1 equal to 0. So finally by simplifying this equation, just you take the 2 as a common. Finally get the minus 5 I1 plus 19 I2, next minus 2 I3 equal to 0. Now finally I will consider this equation as second equation. Let's go for the loop 3. So apply KVL to mesh KVL to mesh 3. KVL to 3. Now go for the third loop. So in the third loop we are having three elements. Two are the resistors, one is dependent voltage source. So dependent voltage source is 4I0 and 4 ohms 12. So 4 into I3 minus I2, because with respect to third loop we are writing the equation 4 I3 minus I2. Next plus 2 negative. Plus 2 negative is nothing but a drop in potential. If you consider the first only 4 I2 plus 4 I2. Next plus 12 I3 minus I1. So like that you have to write the KVL equation. So first equation is with respect to third loop 4 ohms. So 4 into I3, 4 into minus I3 minus I2 plus 4 I0 plus 12 I3 minus I3 minus I1 equal to 0. I3 minus I1. Okay friends. So finally 4 I0. Okay. 4 I3 minus I2. Okay. 4 I0. Okay. Now you have to simplify this equation. Before you are going to simplify this equation, first you have to substitute small I0. What is I0? Is nothing but, already I told that at the time of starting of the problem. I0 is nothing but current flowing through the 10 ohms. So 10 ohms is nothing but that is connected between the first and second loop. So it is the relation between the small I1 and I2. So finally I0 is nothing but here I0 is equal to small I1 minus small I2. So finally here capital I0 is nothing but relation current of small I1 and I2. Then substitute these two currents. Finally get the answer is, just listen, 4I3 minus 4I2 plus 4 into I0. I0 place your substitute small I1 I1. So we'll get the 4I1 minus 4I2. The place your substitute this one is I1. Next plus 12 I3 minus 12 I1 equal to 0. Now you have to simplify this equation. Finally we will get the answer is minus 8 I1 minus 8 I2 plus 16 I3 equal to 0. 16 I3 equal 0. Then you have to simplify this. 8 you have to take the common. Minus I1 minus I2 plus 2I3 equal to 0. Now you have to consider this equation number as third equation. Okay, finally friends, step 3 is over. Then you go for the step 4. So finally step 4 is solve the KVL equations. Solve the KVL equations to obtain mesh currents. Mesh currents. Friends, whenever they are given dependent sources, don't worry, that dependent source will depends upon which parameter, that value you have to find out, then you have to substitute in that equation. Finally get the answer. Okay friends, first you have to solve the KVL equations to obtain the mesh currents. But here how many KVL equations? We are having 3 equations. So finally solve equations first, second and 3 equations. How we have to solve the equations? Nothing but by using calcium or Cramer's rule. Any method you have to use, finally we will get the answer. Okay. Now finally by simplifying 3 equations we will get the small I1 and small I2 and small I3. So after simplify we will get the small I1 is 2.25 amps. Next I2 is 0.75 amps. Next I3 is 1.5 amps. Okay friends, so the determination of mesh currents are over, but our question is not only mesh currents, we need to determine I0. That I0 is already told that I1 minus I2. Okay friends, now finally we have to determine what is I0. So finally then capital I0 equal to small I1 minus small I2. Okay friends, so finally small I1 is 2.25 minus I2 is 0.75. So final answer is I0 equal to 1.5 amps. 1.5 amps. Okay friends, so like that we have to solve the problem by using mesh analysis. Okay friends, just you follow the standard procedure in order to obtain the solution of any given problem by using mesh analysis. Okay friends, if you are watching video first time, please like, share and subscribe our channel and support our channel. Okay friends, thank you. Bye. We will meet in the next class.